So this is just another quick update as to how Charlie's motor controller is going. PCB boards came in early December from PCBWay, and PCBWay did a good job on them. So I've managed to populate one of them to a point that I can start checking out certain features. Just as a kind of comparison here, so this is the modified e-waste Robotech controller that I had pulled out a while ago actually, and so we cut this down so you can see the difference between one that's not been modified and one that has. So we took off about 2.5 inches or so. So what's not in this right now is caps and FETs, and the reason why is that I don't want to put those on until we are sure that everything is working. So I'm going to pop this apart just so you can see. The other thing that's not actually on is the wire sockets that go into the PCB board. So Robotech was kind enough to provide a SolidWorks model on their website, which allowed me to sort of design this board to fit their extrusion. So I managed to get it to fit reasonably well and sort of repurpose their connectors. So all these silk screens that are on the extrusion are really not related to what the actual functionality is. And the USB connector obviously I replaced with a small Pico blade connector for the PM bus connection to the controller. The 5-pin mini or microfit connector has been repurposed for other things like key switch power and some of the higher powered auxiliary circuits like for the contactor, etc. The 25-pin DIN or I guess not a DIN DV connector, it's been repurposed for CAN. I think the encoders come in through here as well, a couple other things. So the status LED lights have changed as well, and fortunately they used off-the-shelf light pipes, which makes it really easy to source replacements. So that's kind of what it looks like. MOSFETs are going to end up along here. There's the existing spring clips that the original had that I'll be reusing again. I do need to put some Kapton tape between the board and the extrusion, and some of the reason is that I've actually got this stuff pretty close because it was a tight fit for all the circuitry. So we'll just go ahead and take off the rest of this. So now we got it all apart. You can see that the backside doesn't really have a huge amount on it. The digital controller chip is down here, which is programmed by the PM bus connection that comes out. We have a bit of, our switchers are here for the power supplies. There's a smart switch for powering the relay and the external rear light as well. So far, there's been a few mistakes on the board that I've noted. Obviously, like reverse BCC ground connection accidentally done on one of the chips, which is over here. There's never a first design that I don't often screw up that. There was another mistake on the MOSFET driver where the driver was expecting 3.3 volts on the logic input because this is interfacing with 3.3 volt logic, and I had 12 volts coming in on that power pin, so it was smoking the MOSFET driver. But other than that, I think the only other problem with the board so far has been that the footprint for the QFN package, 64-pin package for the digital controller, is a tad small on the pins, so guaranteeing that each one is soldered is a bit of a problem. So I still have to walk through all the pins on this part to verify that they're all properly soldered down to the pads before I end up populating the MOSFETs and the caps. Because when putting on a hot plate, it's a real pain if you have a lot of high components. So even with this, with the small caps for the logic supplies, it's been a bit of a problem. So when we check the pins out, the next thing will be caps, FETs, and obviously the ferrules for the wires. So these are soldered in, and then the other half of it is soldered onto the wire, and then you literally just screw it onto the board, which is kind of nice. Makes it a little easier getting it into the board. But yeah, once that's done, it's a lot of software after that. So the CAN bus still has to be brought up, and the control software in the head where the throttle interface goes in needs to also be worked on as well for its CAN. So when all that's done, then there's still the tuning of the MOSFETs as well, which is going to be a whole separate video, because there's certain things you have to be looking for when you're doing your tuning of your MOSFETs to make sure that they're switching correctly and that you're not getting shoot through happening, especially at high currents. The Miller capacitance on these devices does cause little gate blips to occur, and those will cause shoot through, and then you can then end up having major failures. So that's something I'll go through when I go to tune these MOSFETs. Something else that I did, normally I don't really like doing MOSFET bridges along a single row like this, because it ends up getting very hard to share between the switches, and you'll get, if you put one switch group here, one switch group here, you'll end up having not a uniform current distribution. So I'm trying something a little different in that I'm putting the pairs together and hoping that I can control that a little bit better. So we'll see. So yeah, so that's it, and hopefully the next month or so I'll have a new video up describing the tuning of the MOSFETs and showing a little bit more. So until then, stay tuned.